All right, one last example on this part 5. Rewrite each radical expression by extracting perfect squares, taking out perfect squares. Before, on the first one here, we factored it down to prime numbers. 3, 3, 5, and 2 cannot be divided further. You can do it that way. It definitely works. You can save yourself some time by factoring it down, not to prime numbers, but factoring it down to perfect squares. And so 64, if you look at, we made a list of our prime numbers, or not prime numbers, our perfect squares. Here's the list so far, and 64 is on there. So 64, we can extract that whole thing. We're going to take the square root of it. The number that multiplies by itself to give us 64 is 8. So we know that the square root of 8 times the square root of 8 gives us square root of 64. And the whole goal for all of these is finding pairs of numbers. So this is really saying square root of 8 times square root of 8. We can rewrite that as the square root of 8 squared. Squaring something just means multiplying it by itself. And then these two things cancel out. The square root and the square are opposites of each other, and so we're left with just 8. We extracted it. We took it out from underneath the square root sign. We're going to go to do the same thing over here. We're going to find numbers that 75 can be divided by, and we need to look up above. If there's any of these perfect squares that they can be divided by, we're going to use them. Not 4, not 9, not 16, but 75 can be divided by 25. So let's go ahead and put square root of 25, and then think to yourself, what number times 25 would give us 75? That number is 3. Keep them under the square roots. This one's already a prime number, so we can't divide it anymore, and the reason why we chose that perfect square is so that we could come up with the same two numbers multiplied together to give us that. It's a pair of the same. We can rewrite it as square root of 5 squared, and square and the square root cancel each other out. So these two are multiplied by each other, so we're going to keep them multiplied. Now we have 5 times the 8 that we had previously, and we have times the square root of 3. So we turned these two numbers into these 3 numbers, still all multiplied. Let's go ahead and multiply the 8 times 5 gives us 40. And we don't have to put that multiplication sign in there. We can just put a number right next to the other, and we will know that we're multiplying 40 times the square root of 3. And we're done. Go ahead and use these two examples to help you with part 5, extracting perfect squares. Give you a little bit of a head start here. 9 is a perfect square, so we're going to start by taking the square root of 9 out of there. You can check your answers on the back of the notes. And that does it for Lesson 2.